Hi, my name is Ali Mansour Al-Awad and today I am presenting Relational Algebra. It's a course assignment for MIS 309, Imam Abdulrahman bin Faisal University. In this lecture we are going to learn what is relational algebra and basic relational algebra operations and their implementations. Okay, relational algebra. We may describe it as a high-level procedural language. As you all know, data manipulation languages are classified into procedural, non-procedural, graphical, fifth generation, etc. It can be used to tell the DBMS how to build a new relation from one or more relations in the database. It's also described as theoretical language with operations that work on one or more relations to define another relation without changing the original relation. Experts who used it said about it, it's non-user-friendly language, it's a formal language. They have been used it as the basis for other higher-level data manipulation languages for relational database. They are of interest because they illustrate the basic operations required of any DML, and because they serve as the standard of comparison for other relational languages. There are five fundamental operations in relational algebra: selection, projection, Cartesian product, union, and set difference. These perform most of the data trieval operations that we are interested in. In addition, there are other operations like join, rename, and so on, but we are not going to focus about them in this lecture. Our first relational algebra operation is selection or restriction. The selection operation works on a single relation R and defines a relation that contains only those tuples of R that satisfy the specified condition predicated. In simple words, it's selecting tuples from a relation. Here is an example of the selection operation. The input relation is staff and the predicate is salary greater than 10,000. The selection operation defines a relation containing only those staff tuples with a salary greater than 10,000. The result of this operation is shown in this figure. More complex predicates can be generated using the logical operators and, or, and not. In this figure we can deduce that John has a salary of 30,000, Anne has a salary of 12,000, David has a salary of 18,000, Susan has a salary of 24,000. And this is what we have predicated. All of them has a salary more than 10,000. The second relational algebra operation in our lecture today is projection. The projection operation works on a single relation R and defines a relation that contains a vertical subset of R, extracting the values of specified attributes and eliminating duplicates. In this example, the projection operation defines a relation that contains only the designated staff attributes: staff number, first name, last name, and salary, in this specified order. The result of this operation is shown in this figure. Other attributes like position, date of birth, gender, branch number, as not shown in this figure, as what we ordered. The selection and the projection are unary operations. They extract information from only one relation. In some cases, we would like to combine information from several relations. In the remainder of this section, we examine the binary operations of the relational algebra, starting with the set of operations of union, set difference, intersection, and Cartesian product. The union of two relations R and S defines a relation that contains all the tuples of R or S or both R and S. Duplicate tuples being eliminated, R and S must be union compatible. Union is possible only if the schemas of the two relations match, that is, if they have the same number of attributes with each pair of corresponding attributes having the same domain. In other words, the relations must be union compatible. Note that attributes names are not used in defining union compatibility. In some cases, the projection operation may be used to make two relations union compatible. To produce union compatible relations, we first use the projection operation to project the branch and property foreign relations over the attribute city, eliminating duplicates when necessary. We then use the union operation to combine these new relations to produce the result shown in this figure. So London, Aberdeen, Glasgow, Bristol has either a branch office or a property for rent. Another relational algebra operation is set difference. The set difference operation defines a relation consisting of the tuples that are in a relation R but not in a relation S. R and S, the two relations, must be union compatible. As in the previous example, we produce union-compatible relations by projecting the branch and property foreign relations over the attribute city. We then use this set difference operation to combine these new relations to produce the result shown in this figure. The only city where there is a branch office but no properties for rent is Bristol. The fifth relational algebra operation in this lecture is the intersection operation. This operation defines a relation consisting of the set of all tuples that are in both relations R and S. R and S must be union compatible. Again, as in the previous examples, we produce union compatible relations by projecting the branch and property foreign relations over the attribute city. We then use the intersection operation to combine these new relations to produce the result shown in this figure. So, the cities where there is both a branch office and at least one property for rent are Aberdeen, London, and Glasgow. Our last relational algebra operation in this lecture is Cartesian product. The Cartesian product operation defines a relation that is in the concatenation of every tuple of relation R with every tuple of relation S. In other words, the Cartesian product operation multiplies two relations to define another relation consisting of all possible pairs of tuples from the two relations. We should note that it is possible that the two relations may have attributes with the same name. In this case, the attribute names are prefixed with the relation name to maintain the uniqueness of attribute names within a relation. The names of clients are held in the client relation, and the details of viewings are held in the viewing relation. To obtain the list of clients and the comments on the properties they have viewed, we need to combine these two relations. The result of this operation is shown in this figure. So in this figure we can see that there are the names and comments of all clients who have viewed the property for rent. In conclusion, relational algebra is an easy procedural data manipulation language that creates new relations via its different operations: selection, projection, union, intersection, Cartesian products, and so on. By using these tools, we can travel specific data that we are interested in effectively in a short period of time. The information in this lecture has been obtained by the help of this book, Database Systems: A Practical Approach to Design, Implementation, and Management. This is the end of this lecture. I hope you learned something, and thank you for paying attention.